Okay, here we are with page 7. Page 7 begins the Unit 4 review. To complete this page, I may most likely need my multiplication chart and my number line. So make sure to have those handy. On this page, we will be converting from improper fractions and mixed numbers, and then we will be practicing simplify before I multiply. Only worried about the first part for now. Again, that's converting between improper fractions and mixed numbers. If you remember, they mean the same amount, but we can look at it two different ways, and it's to make sure we can understand that. So problems 1 and 2 are converting improper fractions to mixed numbers, and then numbers 3 and 4 are to reverse that, to take a mixed number and convert it to an improper fraction. I feel like the right side of this page is simpler for us, and sometimes the left side can be a little tricky. So the bigger number is on top, the denominator is smaller. That's how I know it's an improper fraction. What I need to do is I need to say, how many times does 5 go into 32? Oh, before I do that, also another thing that for some of us, I had us draw diagrams. So you can draw a diagram, to count how many complete rows there are and how many are left over. Okay. So again, 5 goes into 32. How many times? I have 5, and I have 25, 30, 35. So 5 goes into 32 6 times. That means 6 is going to be my whole number. Okay. So if I were drawing diagrams, that would mean I would have 6 complete rows, 4, 5, 6. And then I need to say, well, how many will be left over? So 6 times 5 is 30. So I take the numerator 32 and I minus 30 of them. And I say, well, how many is left? 2 minus 0 is 2. It does not move anywhere on the number line. And 3 minus 3 is 0. So I would have 2 left over. Let's remember that the denominator does not change when we are converting between improper fractions and mixed numbers. We just want to look at it another way. So let's pretend all these lines were equal, and then I had 2 left over. So if you counted, you'd have 1, 2, 3, 4, 5. Oh, I did 5, not 6. Okay, 6. 1, 2, 3, 4, 5, 6 whole bars, and then 2 left over. So 6 and 2/5. These represent the same amount. We just look at it in different ways. So if drawing a diagram is easier for you, you can do that with all the separate parts. Again, I'm doing this with 42 over 3. So I'm looking at it and I want to know how many times can 3 go into 42. So I'm going to look at my times chart. 39, 42. Oh, it goes exactly into 42, 14 times. So the bigger number is on top, and it means 42 divided by 3. Okay, so 42 divided by 3 is 14. Okay, we're going to bring down our negative. It's still going to be a negative number. So if I were to draw a diagram, I would have 3 of these, and I would have 14 of them. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if you wanted to draw diagrams, there would be 3 in each row, and you would have 14 rows. We want to remember our sign. Moving on to number 3. Now when I convert from a mixed number to improper fraction, a little similar. I feel like this is not really being 2. Okay, so I take 4, the denominator, and I multiply it by the whole number. So we're going to times these. Okay, then I take that answer and I add it to the extra in the numerator. So I'm looking at this and I see 4 times 6 is what? 24. And now I take that 24 and I'm adding how many? 3. Okay. Now I'm going to add 3 to that to find out how many. 4 plus 3 is 7. And I bring down my 2 for 27. Okay. My denominator stays the same. So my final answer will be 27 over 4. And if that is confusing, you can still draw your diagrams, okay? And you can count each part. And you will end up with 27 shaded pieces. And each part would have 4 spaces that you could shade in. Moving down, same thing. I'm going to multiply the denominator by the whole number. Then I'm going to take that answer and I'm going to add it to the numerator. Okay. 8 times 2. Hope you're looking that up on a math chart. Times chart over here. 8 and 2 is 16. And I'm adding my 3. Even though there's a negative here, we worry about that at the end. Okay, I'm not adding -3 or don't stress out about that. Just adding 3. If I need to use my number line, I can. 16, okay, plus 1, 2, 3 brings me to 19. Okay. So 19 is the numerator. And what is the denominator? 8. 8 is still the denominator. It does not change. And then I have to bring back my negative sign. Okay, so -2 and 3/8 is equivalent to -19/8 or 19 over 8, whichever way you are more comfortable saying it. And we're scrolling down. Now we're going to talk about simplify before we multiply. So for this one, I will mask the problems we're not currently working on. Okay. So when I simplify before I multiply, I want to do what? I want to see if the numbers can go into each other. I want to cross reduce before I multiply across. Now when I'm looking at this, 3, 5, and 2, what do these numbers have in common? There's something about them, right? Do you remember? It's not that they're odd or even because I have both of them. It's that they are all, work offline and don't miss a beat, huh? So they are all prime numbers. 2, 3, and 5 right here, prime numbers. Okay, so if these are prime, that means they're as small as they can go. So 2 cannot be any smaller. And 3 and 5 do not go into 8 evenly. That tells me I multiply straight across. So 3 times 5 is 15. 8 times 2 is 16. On to the next. Let's cover this one because we are all done with it. If you need to look at yours for an example, of course you can do that, okay? I'm just covering this on the screen because I can't exactly zoom in smoothly to help us focus on the problem at hand. Now I'm looking at a fraction times a whole number. There's something I can do to help make this easier visually. When I have a whole number and a fraction, the first thing I want to do is draw a line and a 1. Yes, we could also box the terms, but since we know all these problems are multiplication, they're all going to have one box. We don't need to classify it. They already told us. So now I'm looking, and a line and a 1, so now it's like 2 fractions. That's something that is more manageable for me to work with. 3 does not go into 8 or 1. Well, all numbers go into 1. Right? But 24 and 8, well, those go together, don't they? Let's check. Something about that sounds really familiar. So I'm going to look at 8. We're going to 24. 3, that's right. 8 times 3 is 24. So I can cross this off. I'm going to write 8 times 3. And I'm going to write a times and a 1 here so I don't get confused because I'm working with fractions. So for now, I'm going to keep everything a fraction. Okay, now, what can I cross off? Well, I cross off my 8s. I will rewrite this and clean it up a bit for people who like that visual. So now I have 3 over 1 times 3 over 1. Okay. 3 times 3 is 9. And 1 times 1 is 1. Since all numbers have this invisible 1, I can remove it now. I'm all done. I don't really need that one. So the simplified answer is 9. Okay, we only have 2 more to go. Let me scroll up a bit here. There we go. Okay, so I'm looking at my numbers. 2 does go into 12. Look at my chart. 2 goes into 12 how many times? 6. Okay, so I crossed off my 12 and I'm going to write 2 times 6. What about 3 and 9? Didn't we just do that? We said 3 times 3 was 9. Well, we can always double check, right? So 3 goes into 9 3 times. I'm going to cross off my 9 and write 3 times 3. The 3's cancel out. Oh, I can write my times 1 on here too. Times 1. Whoops. And our 2's cancel out, but I did that a little softly. And now the 2's cancel out. Okay. And we can put a 1 right here for the 2 also. So I will clean this up for the students who need that to be cleaned up. Okay. So I'm cleaning this up. 1 over 1 times 3 over 6. Oh yeah, we can make that smaller. Step by step, right? So 1 times 3 is 3. 1 times 6 is 6. But you know, that can still be smaller because 3 goes into 6 2 times, right? So I put my 3 times 1 and then 3 times 2. Okay, I cross that one off, cross that one off. So I have 1/2. It's okay if we break it down to make it easier for us to figure this out. Some of us might be faster and, you know, see that those go into each other and can still be reduced further. If not, that's totally fine. Breaking it down step by step is how I like to do things. Last problem. Okay. So I have 33 and 18. So 4 does not go into 18 smoothly, correct? It goes into 16, but do 18 and 4 share any common factors? Okay, and they do. That factor would be 2 because 2 goes into 16 and 18. Or 2 goes into 4. So 2 times 9 is 18. And 2 times 2 is 4. Okay, cross off my 4 and my 18. Now 33 and 9 also share common factors. Okay, 11. 3 times 11 is 33. And we remember that 3 times 3 is 9. Okay, so even though they're not going into each other quite as smoothly, where I know, 9 times 4 would be 36, for example, we're looking at the greatest common factor. 11 times 3, and then 3 times 3. Now we'll clean this up. Okay, cross that off, cross that off. I could also cross off the 2's. And this 3 that looks really messed up, and the other one. So let me rewrite what we have. Okay, I see 2 over 3 times 11 over 9. Oops. So 2 times 11 is 22. And 3 times 9 is 27. And we have reached the bottom of page 7, right? I'll see you again for page 8. Bye.